In this problem, we're given some information about sine of A and the quadrant that angle A lies in. We're also given some information about sine of B and the quadrant that angle B lies in. And then we're asked to find the exact value of cosine of A, cosine of B, and cosine of A plus B. So let's go ahead and start with angle A and the information that we're given with regard to sine of A. Okay, so as we look at angle A, you'll notice that angle A is between pi over 2 and pi, which means that this angle is going to be in quadrant 2. And our information regarding sine of A is that it's 3/5. Which is information about our opposite side and our hypotenuse. So let's go ahead and draw angle A in quadrant 2. And I'm going to go ahead and make sure I make this an A for my angle measure, not theta, right? Because we're going to have two different triangles here that we're going to be working with. Our opposite side is a 3, and our hypotenuse is a 5. Right, now we can go ahead and use Pythagorean theorem to calculate out our last side. Keep in mind that it lies along our negative x-axis here. So if you want to go ahead and take a few minutes to calculate that side length, go ahead and do that. And you can pause the video while you make your calculations. Hopefully you ended up with a side length of -4. And let's go ahead and do the same thing with our information regarding angle B. They told us that B is between 3 pi over 2 and 2 pi, which is going to put angle B in quadrant 4. So let's go ahead and draw our triangle in quadrant 4. And we were given some information about sine of B. And we have kind of two ways that it's written, right? We have -1 over radical 5, or if we rationalized it, we can use negative radical 5 over 5. Use whichever one is your preference. I'm going to go ahead and use the first one, the -1 over the radical 5. So this is information about our opposite side and our hypotenuse. So let's go ahead and label accordingly. Our opposite side, we'll label this one with a B since we're talking about triangle B. Opposite side is a -1, and our hypotenuse is radical 5. So go ahead and pause the video for a second, and then you can calculate the remaining side length for this triangle. Hopefully you've got a side length of +2. And now let's go ahead and take a look at what they're asking us to find. For part A, we want to find cosine of A. We're going to want to make sure we get this information off triangle A, which is the one that we drew over here on the left-hand side. So cosine of A is our adjacent side over the hypotenuse. And off our triangle, our adjacent side is -4, and our hypotenuse has a length of 5. For part B, they asked us to find cosine of B, which means we're going to have to use the triangle that we drew on the right-hand side. And keep in mind that cosine here is our adjacent side over our hypotenuse. Our adjacent side was a 2, and the hypotenuse was radical 5. If you want the rationalized version of this, obviously you can multiply top and bottom by the radical 5, and this will give you 2 radical 5 over 5. And for part C, we're going to need our formula. Since they asked us to find cosine of A plus B, we'll need to get our sum formula for cosine. And keep in mind you already have this information from the two triangles, and what you're going to be doing is substituting each of these four pieces with an exact value from the triangles that you've already drawn. Alright, and some of these we might already have based on the information that was given in the question. Right, so cosine of A we had as our answer for part A, which was a negative 4/5. Cosine of B was our answer from part B. And I'm going to go ahead and use the rationalized version, so I'm going to use 2 radical 5 over 5. Sine of A was information that was given to us in the problem. Right, we know that that is 3/5. And sine of B, also information that was given to us in the problem. I'm going to go ahead and use my rationalized version here, which is going to be a negative radical 5 over 5. Right, notice at this point I don't have any more trig functions in my formula, which is what I want. And now we can go ahead and simplify what we have. When you're multiplying these fractions, obviously you can go ahead and multiply straight across, so your denominator here is going to be 25. And negative 4 times 2 radical 5 will give us negative 8 radical 5. For my next batch of fractions here, when I'm multiplying, my denominator will be a 25. The subtraction sign and my negative are going to combine to make a positive, and 3 times radical 5 will be my numerator. And now I have a set of fractions that I can go ahead and add together. They already have common denominators, and my terms that are on top are like terms. They are both something radical 5, so I can actually go ahead and combine them just like you would x terms. Okay, my denominator here is going to stay the same as 25. And negative 8 plus 3 is going to give me a negative 5. And then I keep my radical 5. Okay, and if you can reduce your fraction, go ahead and do that. The 5 on the outside and the 25 can reduce. So my final answer here is going to be a negative radical 5 over 5 as a final answer for part C.